Okay, good morning, good afternoon, wherever it is for you. Today we're going to be talking about measuring arcs and angles. Pretty easy assignment. A lot of these that we're going to be working on the next few lessons, not hard. Once again, it's going to be a lot of vocabulary. So the first thing we need to talk about is what an arc is. And so there's two things we need to learn here. One, if you have a circle, right? And you have an angle that comes from the center. This is called a central angle, okay? Central angle. All right? And whatever the central angle is going to be equal to this arc. This is called an arc, all right? So if the central angle is 30 degrees, then the arc is 30 degrees. So these are related to each other. If the central angle is some degrees, then the arc would be the same thing. Now that's not true if it's not a central angle, but it is true for central angles. So arc is equal to angle if it's a central angle. All right, now there's two types of arcs we're going to talk about. We're going to talk about minor arcs and major arcs. Minor arcs are less than 180 degrees, right? Majors are above 180, all right? All right, so this arc right here, so here is an arc, right? And the way we would call that arc by its name, arc AB. All right, arc AB is a minor arc. Okay. Now, arc ACD. Now, you name them in the order. So look, ACD, or ACB. Sorry, not ACD. Fix that here. I can't change it here. Let's change it this way. ACB. So ACB is this arc right here. ACB is a major arc, right? Sorry, I'm having a hard time writing here. So major arc. All right, so AB is a minor arc and ACB is a major arc. And if I called it arc BCA, that's the same thing as ACB. They're both major arcs, right? All right, so those are the big ones, major arcs, minor arcs, and central angles. And so that's what we're just talking about here, right? Here's some properties about central angles and arcs. The sum of the measures of the central angle of a circle is 360. Okay, that's obvious, right? The degrees around a circle is 360. And the central angles add up to 360. That's all that's saying. Pretty logical, right? A minor arc is less than 180 and equal to the central angle, and a major arc is 360 minus the measure of the minor arc. Okay, so what does that mean? If the minor arc is this one, the major arc is the rest of the 360-degree angle, right? The measure of a semicircle. Okay, so let's look at a semicircle for a minute. So if I had a semicircle, I don't know what this pin's acting up for. Okay, so if I have a circle, and this is a semicircle, right? This angle is 180 degrees, and this arc, wow, I don't know why it's doing that, but it is. And this arc is 180 degrees. The angle is 180 degrees, and the arc is 180 degrees. So a half circle is always 180 degrees, right? All right. All right, so another one. This one right here is kind of interesting. Let's put a star on that one. If this angle is 40 degrees and this angle is 40 degrees, right? If their central angles are equal, then their arcs are equal. And the same thing is true for the other way around. If their arcs are equal, then their central angles are equal. Okay? And the arc addition postulate, we don't really have to worry about that. That just says you can add two arcs together, right? So the arc addition postulate basically says if you add this angle with this angle, they make this angle, right? Or sorry, if you add this arc with that arc, they make the whole arc. So if you add arc GF with CF, they're going to make arc GFC. Okay? All right, so AC is a diameter. is a diameter of circle R. Find AB. Okay, well, now listen. If they say find the measure of angle AB, ARC, and you know what? I'm not going to talk about that. The measure of the arc AB. So that's this one right here. So the measure of AB is 42 degrees, right? And then they say find the measure of ACB. Well, ACB is this angle right here, right? It's a major arc, right? So arc ACB is that one right there. So ACB is going to be equal to 360 minus the 42, right? Because this is 42 and the whole circle is 360. So 360 minus 42 is what? 318? 20? Yeah, I think so. 318 degrees. All right? All right, next problem. Find the value of x. Well, what do we know about the central angle? The central angle always adds up to 360. So we have 115, we have 105, and we have 60. So add those together, 5, 10, 6, 7, 8. So we're at 280. So angle x must equal to 360 minus 280. The leftover, right, which is 90. So angle x arc x must be 90 degrees. All right, example 2. This is a 90-degree angle. So these two angles together add up to what? 120 plus 90? 0, 9, 10, 11, so 210. So if those two add up to 210, right? Those two add up to 210. Then this angle x must equal to 360 minus 210, which is, what is that? 150 degrees. All right, so let's do a few more of these. We may not do all of these. Find the measure of arc BA. Well, remember, if it's a central angle, and it is, the arc is equal to the angle. So if the angle is 45 degrees, then the arc is 45 degrees. A mosquito in my house is going to suck my blood, and it's going to make me mad. All right, what about this one? Okay, now this is tricky. They really like to do this to you. What they do is they like to hide information. What you have to notice is that AC is a diameter, right? If something's a diameter, right? If something's a diameter, then you know this arc is 180 degrees, and you know this angle is 180 degrees, right? It's a straight angle. So this arc right here is 180 degrees, right? So if AB is 44, then BC must be equal to 180 minus 44. So it must be 136, I believe. Check my math for me. All right, let's try CD. Well, these are alternate, vertical angles, right? If you have two lines crossing like this, these are equal because they're vertical. So this must be 44. So CD must be 44 because the arc is equal to the angle. And then ACB, all right? ACB, now be careful. ACB is not this angle. ACB is this angle right here. ACB, right? Going around that way. ACB. So that would be equal to 360 degrees minus 44. So 318 degrees. All right. The next two will probably be very much similar to those. All right. So I'm not going to do those two. If you need help with those, just let me know and I'll do them with you. All right. The next thing we need to talk about. I really do think that first half is pretty easy. The second half is we're going to be talking about finding the length of an arc, right? There's one thing here, right? I can figure out the angle. So let's look at this angle, right? You know what? I'll just do it on a separate one. Okay, so if I have this arc, I do not know why it's drawing. It is drawing really poorly today. All right, so I have this circle, all right? And let's say this is, oh, I don't know, 30 degrees. And this is 2, right? The radius is 2, all right? That's a really bad circle. Let's see if I can make a better circle. All right, I'm going to zoom in here a little bit. All right, so I have a circle. The radius is 2. If I ask you what's the measure of the arc, let's call this AB, right? So let's find the measure of arc AB. The measure of arc AB. Well, the measure of arc AB is 30 degrees. Now, the next thing they're going to ask is the length of arc AB. The length is how long that is, okay? There's a difference. Measure of the arc is a degree. The length of the arc is a measurement, right? Like 6 feet long or whatever. So here's what we're going to do. There's lots of ways to do this, but I think the easiest way to do this is setting up proportions. All right, so here's what I would do. I would do the, I could do this 2 ways. So yeah, let's do it this way. 2 pi r, right, is what? Is all the way around a circle, right? It's the circumference. Actually, I'm going to switch this up, right? I want to figure out how long this line is. I'm going to call that x. X goes with 2 pi r. So watch what I'm saying here. The length of the arc to the whole circle, right? How long the arc is to the whole circle is proportional to the degrees 30 to the whole circle. All right, so let me see if I can break this down for you. X, right? X is how far it is from here to here. Well, that distance in relation to the circumference is going to be proportional to the angle to the whole thing. So this is the length of the arc, right? The length of the arc to the whole arc, because the whole arc would be 2 pi r, and this is the arc's degree to the total degrees. If I were you, I would just set up a proportion. All I'm saying is the arc to the circumference is proportional to the central angle to the 360 degrees. And all you have to do then is just fill in the blanks. All right? So let's just do this one right here. We're trying to figure out x. So x to 2 times pi times 2 is going to be equal to 30 to 360, right? So what is that? That's x over what? 4 pi is proportional to 30 over 36. I would simplify that, right? 3 to 1/12, right? 1/12. And then what I would do is I would cross multiply. So 12x equals 4 pi. Divide by 12, divide by 12. X is equal to pi over 3. What am I saying? All I'm saying is, let me erase a lot of this. I'm saying that the distance from A to B along the circle is exactly pi over 3 units long. So all I have to do, now you're going to see something here. We're going to change this up. Your book, right? And you know how much I like this book. Your book has this, right? The length of the arc is x over 360 times 2 pi r. I kind of like to do it this way. I like to say the length of the arc over the circumference is proportional to the angle to 360. Okay? That's the one I like to use, and I'll show you here in a minute. Where is AB? All right, so let's look at AB. So if I want to find the length of AB, I'm going to call AB x, right? I'm going to call this x. So x is proportional to 2 pi r. So 2 times pi times, what's the radius? 8. And that's going to be proportional to how long is this arc, right? How long is this angle? 135, so the arc is also 135. 135 to 360. All right? I would always simplify this first. 135 over 360. I would divide them both by 5. What do I get? 27, I believe. So this is the same as 27 over, divide that by 5. I don't even know what that is. 360 divided by 5, 72, right? 72. You could divide them both by 9. So I think you get 3/8, right? Divide these both by 9. You get 3/8. All right, so this is basically 3/8. All right, cross multiply, 8x equals 3 times 2 times pi times 8. Divide both sides by 8, knock off the 8s. You're left with x equaling 6 pi. And it's going to say round to the nearest hundredth, right? So you're going to have to bust out with a calculator. Remember, if they say exact, you would leave it in pi units, right? But if it's not exact, then you would multiply it out. So 2 times pi is about, what do we got? 18.85, right? So 18.85, whatever units are inches, right? All right, here we go. All right, remember, the key to these is, once again, the length of the arc over 2 pi r is proportional to the measure of the arc, right, over 360. 360. Cannot fix that. 360. The length of the arc over 2 pi r is equal to the measure of the arc over 360. And remember, the measure of the arc is the degrees, right? All right, so let's fill in the blanks, right? The length of the arc over 2 pi r is proportional to the measure of the arc over 360. All right, so the length of the arc, what are we trying to find? How long DE is. Where's DE, this one, right? How long is that? Well, that's x. X over 2 times pi times, what's the radius? The radius is 2. They tell us it's 2, right? That's going to be proportional to what's the measure of the arc? Well, if the central angle is 120, then the arc is 120. So this will be 120 over 360. Simplify 120 over 360, right? 120 over 360 is really just 1/3. All right, so what do I end up with? I end up with x over 4 pi is equal to 1/3. Cross multiply, we get 3x equals 4 pi. Divide by 3, divide by 3, we would get x equals 4/3 pi. All right? Example 2 is 4/3 pi. Excuse me. All right. Let's try number 2. All right? DEA. So I'm running out of room. I wish I would have made more room for you guys, but I didn't. DEA. Find the length is the diameter. Find DEA. So I'm going to erase some of this. Find DEA. Find this arc, right? If the diameter is 7. All right. So here we go. The length of the arc over 2 pi r is proportional to the measure of the arc over 360. So the length of the arc, we don't know. We're going to call it L, or x in this case. X over what? 2 times pi times, if the diameter is 7, the radius is 3.5, which I know some of you are saying, why don't you just use the diameter? I agree. You could just use the diameter if you wanted. So x over 2 pi times 3.5 is equal to what? Is equal to the length of the arc. Okay, so how long, I'm sorry, the measure of the arc. What's the measure of this arc? Well, this is 120 degrees and this is 90 degrees, right? So 120 plus 90 is 210. So 210 over 360. Okay, drop some zeros. I think you can divide them both by 3. So you get, I think when you divide by 3, you get 7 over 12. So that becomes 7/12, right? So I'm going to, I think what I'm going to do is I'm going to throw these out, and then I'm going to have some more room, and then I'm going to do a couple on the bottom. All right. So now we get x over 7 pi equals 7 over 12, right? Cross multiply, 12x equals 49 pi. Divide by 12, divide by 12. So x is equal to 49/12 pi. And if you wanted to turn that into a decimal, you would just multiply it out. Okay? Once again, it's all about this. If you understand this proportion, and it's very logical, the length to the circumference is equal to the measure to 360. All right. Let's do another one. We're going to do 5 and 8. That'll give us some space, right? RT. Find RT if MT is 7. So from here to here is 7, right? MT is 7. Well, what do we know? The length of the arc over 2 pi r is equal to the measure of the arc, right, to 360. So let's fill in the blanks. The length of the arc, we don't know that. We're trying to find it, so it's x over 2 times pi times the radius. If the 2 times pi times 3.5, right? It's going to be equal to, what's the measure of the arc? Well, what are we talking about? RT. So how long is, what's the degree measure of RT? The degree measure of RT is 50, so 50 over 360, right? So what do we end up with? We end up with x over 7 pi is equal to 5 over 36. Drop the zeros. Cross multiply. 36x is equal to 35 pi. Divide by 36. Divide by 36. We get x equals 35 over 36 pi. All right, let's try it one more time. Ready? Last one. If PS is 10, so from here to here is 10. All right, last problem. The length of the arc to 2 pi r is equal to the measure of the arc to 360. All right, the length of the arc, x, to 2 times pi times the radius is 10 is equal to the measure of the arc. What's the measure of the arc? Okay, so what are we trying to find? We're trying to find MRS. MRS is this one right here. Agreed? All right. You may be thinking to yourself, well, I can't figure it out because I don't know what these two are. Ah, but I do, because check this out. Look what's happening. They're trying to trick us, right? Notice what this is. That's a diameter, right? So that's 180 degrees. So this is 180 degrees. So it's 180 degrees plus 50 more, right? So 180 plus 50 is 230. So that's 230 degrees out of 360 degrees. Knock the zeros off, right? What are we left with? X over 20 pi is equal to 23 over 36. So cross multiply, 36x is equal to 20 pi times 23. Divide both sides by 36. We get x equals, I would probably simplify that. I would divide them both by 4, and I'd get 5 times pi times 23 over 9. And I think that's going to be my final answer, right? Let's see, what is 5 times 23? 23 times 5, 15, 1, 10, 11. So it's 115 pi over 9. Okay, I don't expect you to be great at this right now, but I do expect you to get this little formula down, right? Get this little formula down. It's very logical. If you learn this formula, in a few days we're going to talk about areas, and the areas will be very similar to this. You won't have to learn new formulas, okay? So I would really recommend you learn that proportion, and these should not be that bad. Okay, well, good luck with this. If you need any help, drop me an email at MathNinja.Videos@gmail.com, or send me an email, or get on my YouTube channel and drop me a message, and I'll help you out. All right, good luck with this. Take care. Bye.